All right, today we got to go over coterminal angles and what that means and show you how to do these coterminal angle problems. Okay, so let's start with these examples up here. All right, so here's a 30-degree angle. We know we'd rotate it about a third of a quadrant. Let me show you another angle that will be coterminal to that. Coterminal means they're going to share the same terminal side as well. So if I asked you to draw a 390-degree angle, based on our prior skills, most of you would know, to start here, rotate around 360, and then you do the math, right? I've got 30 degrees left over, so I'd rotate up another 30 degrees, and the ending spot of that angle is the same as 30 degrees. That's the idea of coterminal. Remember that phrase co means kind of share or with. Okay, so I could do this forever, right? Every angle has an infinitely many coterminal angles. Let me show you one more and then a negative one. So if I asked you to draw 750 degrees, that would mean an angle that looks like this: 360, 720, and now I have 30 degrees left over again. So another coterminal angle. Okay, so basically they're multiples of 360. We could do it again a third time, a fourth time, over and over and over again. That's why there's an infinite number of those. So we just need to add or subtract a multiple of 360. Okay. All right, we could also subtract. So if I were to ask you to draw negative 330, so I label it right here, negative 330 degrees, well, we'd rotate this way around. So that's 90, 180, 270. 330 is going to stop 30 degrees short of 360, right? So I've got 30 degrees left over, which once again, I'm coterminal. Okay, so I can add 360 to get these, or I could also subtract I said 330, I meant 360, or I could subtract 360 from here to get another coterminal angle. Okay, so to summarize this, write this part down. Let K be any integer and this is kind of our format for finding coterminal angles. We'll take the angle we're starting with, theta. So that was like 30 degrees in my examples. And we add to that 360 degrees times k, where k can be a positive whole number or a negative. Or what if the angle's in radians? Well, if the angle's in radians, then instead of 360 degrees, we'd add 2 pi to that. Okay, so these would be our kind of general formats. I'm going to kind of squeeze this off to the side so that I can still have some room for 11 here. All right, so with that in mind, let's take a look at number 9. Determine 2 coterminal angles, one positive and one negative for each angle. So thankfully, we don't have to do multiple angles. It would take forever because there is an infinite number. All right, so to get one positive, what I could do here is let k equal 1. All right, so basically I'm using this format. Since it's in degrees, I'm doing theta plus 360 degrees k. And my angle 210 is theta. All right, so let's let k equal 1 and see if I get a positive or negative angle. That's coterminal. Okay, so we're going to say 210 degrees plus 360 times k. And I'm going to throw in my 1 value for k. Okay, we're just adding a rotation, simply put, right? So I get 570 degrees. It's no different than taking this 30 degrees, adding 1 rotation to get to 390. Okay, but I'm just have a different starting point. My starting point's not 30, it's 210. So there's one positive coterminal angle. They're also asking for a negative. So that means to decrease this number, we want k to be a negative value of some sort. You can actually have multiple answers to this, right? I mean, if I chose -1 and you chose -2, we're both going to have negative coterminal angles, and they're both okay. Just got to follow the directions. You got some flexibility here. Okay, so now I'm going to make this negative. So 210 degrees plus 360 times a k value of -1. Okay, so I do the math and it gives me negative 150 degrees. Meaning if we were to draw these two angles, they'd have the same ending spot as 210. All right. Okay, now 10's a little bit different because they actually give you a negative angle to start. So let's see what you can come up with for appropriate K values to get one positive and one negative. Okay, I'm going to go ahead and pause now and give you a couple minutes to try number 10. Okay, don't be a robot and just use the same K values. Use your brain and think about it. So when I use a K value of 1, it gives me negative 40 degrees. The directions say one positive, one negative. So I've got a negative, check. How do I move on to a positive? I wouldn't want to use a K value of negative 1 because that'd give me negative 760. Okay, so I'm going to need to make another positive K value. You could use 2, you could use 3, you could use 4, whatever you want, as long as it produces a positive coterminal angle. Okay, I'm going to keep the number small, just use 2. So that's 720 plus the negative 400 gives me 320 degrees. Now I have one positive and one negative. Okay, the format stays the same with radians, except now we just have a little bit different math. Okay, so let me take you through 11, and then you'll try 12. 3 pi over 4. Don't change it to degrees, because then if you change it to degrees and do the math, then you got to change it back to radians. Okay, so let's just deal with the radians and deal with the math. So let's start by using a K value of 1. Okay, so I'm still using the same format, theta plus 2 pi k now. So theta is my 3 pi over 4. So I have 3 pi over 4 plus 1 rotation, so that's 2 pi times 1. Okay, don't freak out. We can handle this. All we need is a simple common denominator that you've been doing for years. 2 pi times 1 obviously is 2 pi. I don't think I need to rewrite it just to clean that up. So this has a denominator of 1 right now. So to get a common denominator, we just need to multiply this by 4 over 4 to get this expression. Okay, so the 3 pi over 4 is still here. Plus, and now this is going to be 8 pi over 4. Now I have a common denominator, and that should make mathematical sense, right? It was 2 pi, now 8 divided by 4 is 2. So I just changed its form so that I can add it together to get 11 pi over 4. Okay? So there's one positive coterminal angle. I've got that. To get a negative one, it makes sense that I probably got to use a negative K value. I got to make this number decrease. All right, so I'm just going to try to squeeze it over here. Leave some room for 12. All right, so let's let K equal negative 1 now. So the same format. So 3 pi over 4 plus 2 pi times negative 1. So getting the common denominator is going to look just like what I did over here. Still got to multiply it by 4 over 4. Okay, to get this expression. So I have 3 pi over 4 plus a negative, or you can just put minus if you want, minus the 8 pi over 4. So 3, take away 8, just these are like terms, so we say negative 5 pi over 4. Okay, so there we go. I got one positive, I got one negative, we're all set. Okay, have you try number 12. Let's kind of free up some space here. We saved some space, and then we didn't use it all over here for 10. Hopefully you didn't. So here, we'll use all this space for 12. Your turn. Go ahead and pause and find one positive and one negative. Coterminal angle. All right, so I let K equal 1 to start. You don't necessarily have to do it that way, but I did. Keep these numbers small to start. So I'm going to multiply this by 3 over 3 to get 6 pi over 3. So negative 5 plus the 6 is 1 pi over 3. So now I have one positive coterminal angle. Okay, so I definitely want to go to a K value of 2 because that's just going to increase that value higher to another positive. We want to go the other direction to get a negative. So now I just change it to a negative 1, which means now we're just going to make this minus 6 pi instead of positive 6 pi over 3. So negative 5, take away 6, we're at negative 11 pi over 3. Okay, the other day when we introduced radian measurement, I went through and started with this arc length and I did a full revolution. Not this sheet of paper, but a different one. Said, all right, what's one full revolution? It was 2 pi r, and we used that for some clean common conversions. They're not always clean common angles, though, okay? So if it's not, sometimes we just got to take s and divide by r, and we didn't do any problems to apply that. But let's take a look at one that does apply that. Why don't you turn the page over to like these practice problems. I'm not sure what page number it is on there. I don't even think they are numbered, but turn the page to find problems like 21 and 22 here. Okay, so given a circle of radius 85 yards, I'm going to do 21. You end up doing 22 in your assignment today. So let's go ahead and create this setting here. An angle intercepts an arc of 80 yards. So what we have is a circle, and we've got an angle inside it. So it gives you a little visual aid on this, okay? So we've got an angle that looks something like this. The radius from the center to the edge is 85 yards, no matter where you want to label that. So this is 85 yards from there to there. And then it says the angle intercepts an arc of 80 yards. So this distance here is the s equals 80. Okay? So express the angle in radians. So we have a formula for that. We just have to remember the definition of radians, simply put, is s divided by r. That's it. Okay, so write it down here again so you have it. Theta equals s over r. So it's 80 yards divided by the radius of 85 yards. The units cancel out. We could reduce it. Sometimes they say to put it in decimal form. Let's just throw in decimal form right now, whatever 80 divided by 85 is. All right, so punching that in, we get approximately 0.94, and we'll just put the word radians next to it. Remember, if it has pi in it, we just assume it's radians, but if it's something that didn't involve pi in the calculation, we should label it so we don't think it's degrees, okay? So that's it. I guess we can try 22 right now as part of your assignment so you can get some feedback. Why don't you try 22? The only difference here is after you get in radians, they want you to convert it to degrees. So use your conversion factor, okay? Go ahead, pause, try 22. All right, so 30 feet over 60 feet, feet cancel. So it gives me 1/2 radian or 0.5 radians, and then it says, though, if it said leave in radians, we'd be done. All right, but it said put it in degrees, so then our conversion factor we worked on yesterday, multiply by 180 over pi. If you're confused of where to put the pi, remember pi has the word like radians next to it if that helps, so at least those cancel out. All right, so go to your calculator and just punch in 0.5 times 180 over pi. It gives me approximately 28.648 degrees, okay?